Here's a video demonstrating how Device Authority's Keyscaler platform, integrated with Azure Key Vault services, provides many operational, security, and cost benefits. Are you building IoT solutions and are facing these challenges, where you just don't trust public CAs and want to use your own private key? Or perhaps dedicated HSM costs are too high, but you need a secure way to store your private key following the best security practices. And then, how you can use your private CA and private key combination to sign your IoT device certificates. In this video, we will demonstrate how you can achieve all of the above challenges with one solution. This can all be achieved because of a single integration of Keyscaler platform with Azure Key Vault. At Device Authority, we have built a connector using our Epic API framework or Enhanced Platform Integration Connector to leverage Azure Key Vault services. This enables the use of Key Vault for private certificate authority services, including the use of customer BYOK model, and provides a secure mechanism to store private keys as a very cost-effective alternative to using a dedicated HSM. Through Keyscaler Control Panel UI, we can use the CA and private key in Key Vault as a quick and convenient way to get device CSRs signed. To accelerate IoT deployments, what is needed is an out-of-the-box PKI solution that addresses the challenges of trust in public CAs and cost-effective alternative solutions to expensive HSMs, and the ability to manage and control your CA and device certificate provisioning without compromising on security. Let's take a look at a detailed flow of how this would work. From the Keyscaler control panel, administrator logs in and creates a new intermediate CA, selecting the Key Vault option. Key Vault sends a request using the Epic connector to Azure Key Vault to generate a key pair. The Azure Key Vault generates a key pair and returns a success message back to Keyscaler. Next, Keyscaler generates a CSR digest. This is sent to Key Vault to get signed. Key Vault signs the digest with the stored private key and returns it to Keyscaler. Next, Keyscaler generates a CSR from the signed digest and makes it available to be manually signed by an external root CA. The root CA signs the CSR certificate, and then the signed certificate is returned to Keyscaler and stored. The intermediate CA creation is now complete. Next, let's take a look at the device CSR signing flow. First, the device sends a CSR to Keyscaler. Keyscaler checks the policies and extracts the digest from the CSR. Keyscaler sends the digest to Key Vault to get it signed. Key Vault signs the digest with its private key and it is returned to Keyscaler. Keyscaler creates a signed certificate from the signed digest and stores the certificate in a local database. And finally, the signed certificate can be downloaded or provisioned automatically to the IoT device. We start with creating a new certificate authority with its private key generated and stored in Azure Key Vault, and then getting it externally signed by a root CA. We also show how a device CSR can be easily signed and downloaded to your IoT device using Keyscaler's simple and intuitive control panel user interface. And now for the live demo. We start by creating an intermediate CA by logging into the Keyscaler control panel, which takes us to the dashboard. From here, we navigate to the Managed Service Connectors. Here we've got a couple of pre-configured profiles. The one we're going to use is called Mat Key Vault, and the Key Vault that we're going to use is Keyscaler with Key Vault. Next, we navigate to Create Certificate Authorities. Here we're going to add a new certificate. To create a certificate authority, we need to fill in a few details. For the common name, we're going to call it Demo int CA, and we need to fill in a few extra details like the organization unit, the organization name, and a few other things like the locality, state, and country. For this intermediate private CA, we need to configure a couple of advanced options. One, we want to get it signed by an external root CA, And 2, we want to store its private key in Azure Key Vault using our Epic connector called Mat Key Vault. Then we can click on the Generate button. This starts the process of creating a CA. As we can see here, the CA is still inactive. If we take a look, we can see that the CA is still awaiting a CSR. We can use MQTT-FX to take a look at the messaging between Keyscaler and Azure. We can see here the successful messages being exchanged. This shows Keyscaler using Azure APIs to get a key pair generated and stored in the Key Vault. Now let's take a look on the Azure portal. Here we can navigate to our Key Vault called Keyscaler with Key Vault. By selecting the key option on the left-hand side, it will show all the keys stored in this Key Vault, including our new key called Demo int CA. This is the key pair that got generated via our Keyscaler connector to Azure Key Vault. Now let's go back to Keyscaler, and here we can see that the CSR has been generated and highlighted in blue. We'll take a copy of this CSR and then paste it into a text file called intermediate CA. Once the file is saved, we can then go to our root CA shown here in KeyStorer Explorer application and select the option to sign the CSR. We select the file and open it within the KeyStorer Explorer application. Here we just need to check a couple of extensions. One of the configurations is to check that the CA is an actual CA. We do this by checking basic constraints. The subject is a CA box is checked. We need to check a couple of other things and then save that CSR reply. We can then open that signed certificate within KeyStorer Explorer app and take a look at the PEM format of that file. We'll take a copy of this PEM and copy it back into the Keyscaler application and submit that as the signed CSR. This changes the CA status to active and therefore completes the intermediate CA creation in Keyscaler. The next part of this demo is to use this intermediate CA to sign a device CSR. Next, we need to generate a CSR. To do this, we can go back to our KeyStorer Explorer application and use this to create the CSR file. We just checked a few settings and then save that CSR file locally. Once this is created, we can open this file in KeyStorer Explorer and check any certificate extensions and apply any new ones that are required. Next, we just need to check the PEM file, copy this PEM CSR request and copy it back into the Keyscaler application. We can see here that the Keyscaler application has read the CSR. We can now sign it. The signed certificate is displayed there, and if we take a look at the MQTT application, we can see from the messaging that the Azure Key Vault connector has been invoked and the private key stored there has been used to sign the CSR. We can now download this signed certificate to our local machine and then provision the IoT device with it. Once it's downloaded, we can take a look at the signed certificate using KeyStorer Explorer application. Here we can see that the IntCA has been signed by our root CA, and we can see that the IoT device certificate has been signed by the intermediate device certificate. This has been verified when we check the issuer of the device certificate. This completes the live demo. And here's a summary of what we showed. We showed the intermediate CA creation in Keyscaler as a new certificate authority and its private key, both generated and stored securely in Azure Key Vault cloud infrastructure. We also showed through Keyscaler's control panel and CA tools how a device CSR can be easily signed by a new CA and downloaded to the IoT device. Here are the benefits of Keyscaler integration with Azure Key Vault services. It helps to accelerate deployment by providing an off-the-shelf IoT platform with certificate signing and certificate provisioning capabilities to devices within Azure IoT ecosystem. It also enables the use of Key Vault for private certificate authority services, including the use of customer BYOK model. It provides a secure mechanism to store private keys as a cost-effective alternative to using a dedicated HSM. And finally, the integration provides the flexibility of having either public or private certificate authorities option for certificate signing and issuance. Thank you for watching. If you'd like more information, please do get in touch.